Top2V. Dear friends, for astronomy enthusiasts, the simplest way to express love for the celestial bodies in the sky is to quietly observe them every night. The night sky not only brings a sense of relaxation after a tiring day of work, but behind each of those twinkling stars lies a story from billions of years ago, of the present, and even the future. Stars have been observed throughout human history. Through experience and knowledge, astronomers estimate the total number of stars discovered in the known universe is about 70 billion stars, with countless types of stars having different characteristics. Among them, red giant stars are one of the most noticed types, simply due to their enormous size. Additionally, it is predicted that in about 5 billion years, our sun will also become a red giant star. So what is a red giant star? What will the future of the solar system be like when the sun becomes a red giant? Let's join Top2V to find the answer in today. Wishing you relaxing moments with Top2V. Now, let's explore together. Stars are defined as spheres of plasma that emit light and maintain their shape due to the effect of gravity. The closest star to us is the Sun. It is the only star in the solar system, providing light and heat, warming the planets, including our Earth. For our classification, we can emit light and maintain shape due to the effect of gravity. For our classification, we can emit light and maintain shape. For our classification, we can emit light and maintain shape due to the effect of gravity, such as temperature, color, light, spectrum, or size, etc. But mainly in scientific research, astronomers distinguish stars by their spectrum. Among them, they are divided into 7 different spectral types, sequentially as spectral classes O, V, A, F, G, K, and M. They correspond to colors from blue to red. Additionally, these spectral classes also indicate decreasing surface temperatures. Therefore, if a star has a spectral class O, it will be much hotter than a star with a spectral class M. In today's video, we will explore the nature of red giant stars. If following the spectral classes above, red giant stars will have a spectral class M, being one of the stars with the lowest surface temperatures in the universe. But conversely, their size is usually very large. Because this is an old star, they are at the end stage of stellar evolution. When entering the final stage of stellar evolution, the outer shell expands, causing the radius to increase, tens or even hundreds of times the radius of the star in the main sequence stage. Since stars are born in the universe, they continuously convert hydrogen into helium in their cores through nuclear fusion reactions. For newly formed young stars, the larger their mass, the faster their main sequence stage ends, and all nuclear fusion reactions in the core occur more intensely. Therefore, typically, stars with large masses have much shorter lifespans compared to stars with small or medium masses. When nuclear fusion reactions in the core are maintained steadily, their pressure balances with the star's own gravity, keeping the star stable and maintaining its state. But towards the end of their life, nuclear fusion reactions in the core gradually decrease. At that point, the star's gravity gradually overcomes the pressure from nuclear fusion reactions in the core, causing the star to compress. This results in the core temperature rising, accelerating hydrogen burning, gradually leaving behind a helium core. In contrast to the star's core, the outer shell still contains a lot of hydrogen. Due to the inner shell being intensely heated, the outer shell absorbs more heat, causing it to expand outward, making the star increase in brightness and size and then become a red giant star. Typically, red giant stars expand to diameters from 100 million to 1 billion kilometers, 100 to 1,000 times larger than our Sun today. Because the energy of these stars is spread over a large area, their surface temperature is relatively cool, only reaching from 2,200 to 3,200 degrees Celsius, about half that of the sun's temperature. This temperature change causes the stars to shine in the redder part of the spectrum, leading to the name red giant star. Of course, at this time, most of them exhibit a spectral class M. Once transformed into a red giant star, the star's life will not be prolonged. When the core of a red giant star contracts further, nuclear fusion reactions in the core weaken, allowing gravity to completely dominate. That will be the moment of the star's collapse. That event can end in a supernova, creating a neutron star or a black hole. And it might not go through a supernova, only leaving behind a white dwarf and a nebula. This greatly depends on the mass of the star's core before collapse. That is the life cycle of a red giant star. Scientists predict that our sun, towards the end of its life, will also expand to become a red giant star. However, due to its relatively small mass, the sun can still maintain its main reaction chain for about another 5 billion years. That means it will take another 5 billion years for the sun to swell into a red giant star. At that time, the sun's outer layer will expand, engulfing at least the two inner planets, Mercury and Venus. Moreover, when the sun becomes a red giant, its outer layer might even swallow Earth's orbit. Of course, no one wishes for this to happen, but it is a natural law of the universe. Where there is Earth, there must be death. As current mass, scientists predict that when it goes through the red giant phase, it won. Instead, the sun's collapse at that time will only form a white dwarf, while its outer layer will be ejected into space, forming a nebula. In recent years, astronomers have gained a clearer view of some red giant stars. Betelgeuse is a typical example. It is one of the most famous stars in the sky. Currently, Betelgeuse's radius is estimated to be about 764 times that of the Sun. If it replaced our Sun, its outer layer would expand nearly to Jupiter's orbit. That means the four inner planets, Mercury, Venus, Earth, and Mars, would all be swallowed. In the autumn of 2019, scientists noticed Betelgeuse began to dim significantly, losing about 2/3 of its brightness. Some scientists at the time believed Betelgeuse had entered the final stage of its life and might be preparing for a supernova event. But by April 2020, Betelgeuse unexpectedly brightened back to normal. One study suggested that the dimming in 2019 might have been caused by a cloud of cosmic dust. However, it's certain that before long, Betelgeuse will meet the conditions to produce a supernova. At that time, from Earth, we will witness a spectacular light show in the sky. Many scientists predict that within the next 100,000 years, Betelgeuse could explode at any moment. As current mass, the remnant after Betelgeuse. Let's wait and see how Betelgeuse will end its life. So today, Top 2V and we'll explore the truth about red giant stars together. Wishing you all an enjoyable video viewing. Now, please continue to choose the video on the left or right side of the screen to join Top 2V in unraveling the mysteries of the universe. See you in the next videos. Goodbye, everyone.